Machine Shop Magazine. Thanks for attending today's webinar entitled Tips to Enhance Your NC Process. This presentation will focus on how you can leverage NC programming functionalities to meet quality goals and get parts out the door faster. Today's presenter is Hari Sridharan, Vice President of Engineering for Cimatron Technologies. Hari holds a bachelor's degree in mechanical engineering. He worked for the Indian Space Research Organization for 9 years before he moved to Malaysia to take up a career in the mold-making industry. He has extensive knowledge of machining, including expertise in 5-axis machining. He's been with Cimatron for more than 17 years, and during that time, he's worked with the mold, tool, and die-making industries. He's currently Vice President of Engineering. As Hari speaks, feel free to type questions into the question pane at the right hand of your screen. At the end of the session, we'll answer as many of those questions as we can. If we don't get to your question, we'll follow up with you via email or phone. Also, take note that a recording of this presentation will be available in a few days. We'll send that to your email as well. Hari, if you're ready, please begin.
Thank you, Matt, for that wonderful introduction. Welcome, everyone, for this webinar. We will be going through quite a bit of information here. The agenda, as you have seen in the invitation, is toolpath efficiencies, how we can deliver tools faster, optimized machining strategies to ensure superior surface quality, and we will also see how the ultra-high volume material removal product volume mill can enhance the time savings, and also how a system with CAD/CAM tight integration will enhance your productivity. Before I start the presentation, I would just like to say or introduce our company. Cimatron is a world leader in CAD/CAM solutions for mold, tool, and die, as well as discrete part manufacturing. We have been in business over 30 years. We operate in more than 35 countries all over the world and have more than 40,000 installations. An independent survey states that Cimatron customer delivers tools faster than the industry best in class. I myself, having worked in aerospace industry and dealt with a variety of machining materials, and then getting into mold making industry, and also spending about 17 years in the CAD/CAM software industry, it has given me plenty of opportunity to go around the country, all over North America, Canada, US, and Mexico, along with my expertise in the Far East from Malaysia, working for some high-end Japanese companies, has exposed me to different tool and die making companies, which allowed me to learn and understand the demands, which definitely helped my career at Cimatron. In the process of visiting several customers in the industries where they have different processes, what I have realized is in mold making, it is very unique that no two mold companies work exactly the same way, and they tend to claim that theirs is the best process. Having said that, there are definitely a lot of commonalities between the companies, and how these processes are optimized to get the most out from the software as well as the machines you use on a daily basis. Let's get into the nuts and bolts of this webinar. Basically, we will go over different areas, and I will be switching back and forth from the presentation and to the software to show you some examples what I mean by when we talk about different topics. As NC programmers, we always wanted to have some CAD tools available for us, but seems like most CAM systems do not give much importance to the CAD tools. However, Cimatron as a company believes that it is very important to have a complete access to the CAD for an efficient NC programmer. It is always beneficial to spend a little extra time on programming, which can significantly improve the machining times and also the tool life. I remember one of the programmers saying that programming fast does not mean that machining fast. You can program something very, very fast, but you can end up spending few extra hours on the machine, which is also important and which can cause delays in the delivery. So it is very important that we have the right tools for programming and also efficient tool paths. Of course, time is important, so you should be able to calculate these tool paths faster. I would like to go over one example where how a CAD tool will help save some time. And when I say CAD for NC, we mean design for manufacturing. It is not a tool for designing a mold or designing a die, but it is just a tool for us to help develop some surfaces and areas which we wanted to deal with for efficient programming. So let me open up the Cimatron. First I will look at the part which we will be seeing some tool paths on. Here is a block of core which we wanted to machine, and I'm sure many of the CAD systems have some simple CAD functionality to patch holes and other things. So most times what happens is in this type of part there are cases where you go and fill each hole with a surface, or there might be some tools like one of our Cimatron tools is modify the boundary and just fill the islands and keep the original and only inside. So it goes and just picks up all the little islands on this, and it also gives you an option to not to select some of the things which I really wanted to go inside that and machine it. I can select which one I want to close, which one I don't want to close. So I can just apply and it will create those simple surfaces patches. Similarly here there is another one and maybe another one here. It's pretty fast. There's not much involved with this. I'm just going and patching these holes, which is again, it's a CAD operation, but it is very important to have in a CAM system to efficiently program. Now, most of us probably will do to this extent and get it to the machining. But when I look at this part, I see that there is a lot of areas we will do electrodes, and I would like to not to get into those areas unnecessarily machining it, especially in the finish cuts or even in the roughing cuts, which will slow down the machining process and causing a lot of increased machining time. Many programmers tend to continue to program a part with that, and it's not that you don't get a part, but it may not be the most efficient way of programming it, and also may not be the most efficient time on the core cavity machining when we look at that. So I'm going to, as I was showing you, this is what normally most of us do, but I want to show you what is the effect of that, and then we will go into see how we can make it better. So here I just took that information like what we had. We patched these holes and we created the tool paths here. Several tool paths, starting with the roughing and several roughings, which we will talk a little bit further. I wanted to show specifically one area here. Let's look at this toolpath here. This is a particular type of toolpath I have created. And now, if you look at, this is a finish cut with a very small, nice down step. You can see that at each slot, the tool is going to slow down because it is trying to enter into that whatever is possible. It's not gouging or anything. It's not doing the wrong thing, but that's how it sees that the tool can fit in. So you can see that if you focus on the area, it is curving in all the way from top to bottom. And this is true for every area where it is trying to get in, even here. Possibly, we are probably going to make an electrode here, and getting into this area is not going to help much. It's only going to be making the tool motions slow down and also increase the machining time. And not only that, it also can lead to faster tool wear. So this is very, many times we don't really pay attention to this, but it could increase the machining time tremendously, especially when you have the machines with the high speed. It has to slow down and pick up, slow down and pick up. It definitely makes a huge difference. So this could be for any type of programming. Even it could be for roughing, finishing, remachine. Many things can have these type of small areas where you don't want to get the tool in, but because the feature on the part makes it happen, you end up programming it that way, and it's not very efficient to have this type of toolpath. So what do we have? What will help us is having a CAM system, or taking time to do it. That is what is most important. Now, if I really have to go and fill up these areas, each one, it might be time consuming, depending upon how you do it, what kind of tools you have in your CAD system. I wanted to show you that Cimatron, since we believe that it is important to make the programs efficient, have some tools so that we can do that type of filling and making it efficient programming. I will show you quickly here. So first I wanted to do is I wanted to just take all the green surfaces, which is my core block, and then I wanted to fill up all this area. So selection methods are very, very important. And as again, I will repeat probably these few times, Cimatron focuses on mold making companies. That's what we develop the software for CAD and CAM. So we have tools which make selection process also easy. For example, here I have different methods. Like if I want to pick up a pocket, if I want to just pick up the rounds, or if I want to pick up a hole, or if I want to pick up a smooth surface edge. So this is the one I'm going to use. And you can see that I just pick up one surface, and what it does is it just flows around all around and sees that wherever it is tangential, as long as it is smooth connection, it will pick it up. And what is that it did not pick up is as soon as it encounters a sharp corner, it says, oh, okay, I don't think this is part of the selection the user wanted, so it will leave that out. It doesn't mean that I cannot select. I can select any of this, or I can unselect some of the areas. For example, in the middle here, I really don't want to pick the radiuses because they are smooth. It just picked it up. I can unselect them. Sorry. Okay. And when I drag it from left to right, it only picks up the surfaces which are completely enclosed. So now I just needed these things to come back, so I can go back and just pick it right to left, or it is left to right, I guess. Again, as I said, if there is anything missing, for example, in this area, I wanted to include this in my selection, I can go back and manually pick. So basically, this is what I wanted to look at and try to work with. As you can see, the bottom one is selected, so I can unselect that. And I say hide other. So this is the area which I really wanted to fill up, all this area which I wanted to fill up. What I can do is, we have very, very extensive CAD tools which come with our CAM system. I'm going to unstitch this as a group and say, okay, make this as one group, and then just go and fill up those areas. We have what we call it as close open gaps. I just pick the whole part, and it knows which are the open areas. It automatically identifies and picks it up. And all I have to do is, I just wanted to close those. So you can see that it goes and does it automatically. This probably would take close to 30-40 minutes, which many times programmers do not want to do it because it takes time in CAD systems to do it. But if you have right tools, it's not very difficult to do this. And also, you might notice that it did skip this area, because it didn't understand automatically how to fill this. Really not a problem. You can just do it manually. We can just say, okay, I want to blend this edge to this, and done. And I wanted to create a composite here. I want to chain not by outer boundary, and another one. I want to start from here and end here. So I have two boundaries made, and just say that's it. As you can see that in a couple of minutes I have finished really what I wanted to machine, because all those slots and things like that. And if I really don't want to fill up this area, I can always go and edit it and take out that profile. I just wanted to show you that even if it is covered like this, it can fill in. I can always go and edit it, because Cimatron's CAD is a feature-based parametric modeler. I can say, okay, I don't want to fill up that area, just do the rest. So you can see that it is not filled in. So this type of CAD tools for programming is very, very useful, and I think it will save a lot of time. The rest of the holes are not big deal. As we did on the first one, we can just pick it up and say, okay, I want to just fill the islands inside, and few clicks, we're done. So if I go ahead and program this now, I would probably get a better toolpath in the areas where I have shown you that it was trying to enter into the slots and making the machine to slow down at every point. And when we are doing a finish cut with smaller down steps, there could be hundreds and thousands of passes with so many places it is slowing down. It will definitely show up on the machining time. And also it leads to tool wear out faster, and I think it is important to make the programs efficient, and we should always think about spending a little bit more time on the CAD geometry, which takes few minutes, but it saves tons of time on the machine. I'm going to show you the same tool path with, now that we have filled all these areas, and when I calculate it, what would it look like? Let's see. Lower portion of it, no, not that. Not that one. Finish 3D. Not that one. Yeah, here. So here you can see that it is, since this surface is there, it is just going straight. There's no reason for the tool to stop anywhere, and it is nicely. When you look at the part also after that, it will look nice if there's no digging in there, and unnecessary timing. Now, some of you must be wondering why is that this area is not machined. I'm sure we will get into that soon, but just to make sure everybody understands that it is not that the software did not calculate, but it sees that, okay, if it goes down, it's going to gouge. So here it is fine, no problem, but anything in between here and here, the tool will gouge with the holder, so it automatically stops the toolpath there. Now let's get on to the next topic, which is knowledge of remaining stock. This is very, very important as well to programming. Nowadays, most CAM systems do have this type of feature, but what is different and what would make sense and what is Cimatron believes is the many CAM systems have the stock remaining. You can save that as a stock and you have to feed it as an input. Some systems do have some type of automatic. You have to refer to a particular procedure or something. But in Cimatron, what we have done is we have automated it in such a way that it does not require any user intervention. For example, if I have a tool with a 2-inch bowl and I left some material and then I want to go and take a 1-inch bowl and want to semi it, it automatically knows that there is only stock on the walls which I want to semi, and also areas where the 2-inch could not get in. That's where it's going to get in. So it automatically updates the stock at each stage. You know, you can see that there are many, many toolpaths here. Actually, in fact, I would like to bring another part to show you the effect of remaining stock on this particular part. Let's look at this one. It's a 4-inch bowl. I took the largest cutter I have with strong inserts, and I got rid of all the stock I wanted to get rid of it. And then I'm going with the 2-inch bowl. And you can see that it's only entering into the area where it has left material. In this corner, you can see that it has a couple of passes. And then as we go down for more and more smaller tools, it automatically identifies the areas where there is material. For example, the 2-inch couldn't get inside this pocket at all. In fact, the 2 inches lengthwise it is small, so it couldn't get into this pocket all the way down. So each procedure, each roughing, as you keep going, the system automatically updates the stock. Not only it's just updating the stock by it is also gouge checking at every point and then updating the stock. This is very, very useful. It's not only just in 3-axis straight up and down. It can be applied to multiple sides. For example, if you are going and cutting from the side, it automatically updates when you go and create a orientation that you want to cut from the side, a coordinate system to machine that. It sees that previously you have done the work from the top, and it will update that side, and it will only machine the area where there is material. So it is not just only one side, or the user doesn't have to do anything. He doesn't have to save the stock and then bring it into another toolpath and say that, okay, this is the orientation. It is automatic built in to the system. So I think this helps a lot to find out where is the exact material, and it is very important. I also wanted to show you another example. The knowledge of remaining stock is not just for the 3-axis type of thing, but it can be even for just a simple pocketing. You know, this is a part which illustrates the thing what I want to bring it up. Here I have a toolpath which is a 2.5-axis pocket. I just want to finish that area with a pocket, and then I wanted to profile that because they are straight walls. There's a fitting, so I wanted to use the cutter compensation and finish it nicely. And then I went ahead and drilled that hole in the center. As you can see that the 2-axis pocket which removed this material. The 2.5 axis cleared that pocket, finished it. Now the drill automatically knows where to start. You can see that it is starting from here, not from the circle here, because the drilling also will identify the stock remaining in the part. It takes the 3D model and says that, okay, I have material starting from this height. And in fact, if I go and measure that, that in this height should be the, there is a clearance, of course, 1 mil or 0.40 tau above it starts the drilling. So it automatically understands not only just for 3 axis but also 2.5 axis and drilling. Now once this is done, now I'm going and doing a roughing. When I do the roughing, you can see that it automatically knows that there is no material in the center. It's only on the sides up to this level, so it's only cutting that area. Although the procedures before that did not use any surface information, it identifies that as a stock and it keeps track of it. And this is, I think, is very unique and it is very beneficial to avoid unnecessary air cutting. If you're cutting air, we are wasting time and money, and that's when many times we end up seeing the boss walking by the machine and says, why is that cutting air? So I think it is very important to create efficient programs so there is very minimal air cutting. One another important thing about stock is also that it is very important to program it efficiently. How many times we have thought to ourselves that, I wish that I knew that that cutter won't get in that area. Now I have to go and reprogram it or recalculate the tool path with a different tool. So this is something which is very unique also to Cimatron. It helps enhance the programming time and also the confidence of the programmer. I will just delete this whole tool path here, and we will start with a new one. We want to create a 3-axis tool path, and we wanted to define the stock. Again, ability to define stock in many ways is very important. This one is taking the bounding box of the part what we have. You can do many different ways. You can define by surfaces. Let's say if it is a casting and you have everywhere half-inch material, you can define that by surfaces with an offset of half-inch. And when you rough it, it's only going to go and cut where the half-inch material is. Or you can define it by a contour or by a box, or you can get it from a different file. Maybe you have a casting file you want to bring in, that is your stock, or multi-axis stock. So in this case, we'll just go with the bounding box to show you what I wanted to show. So I'm going to go and create a procedure, volume milling, and I wanted to use a tool. Let's see the 4-inch one, the 4-inch tool here. Now, I did not do anything, and I'm just going to get some parameters from the tool. Let's make it as we want to go 100 tau down step, or maybe less. To show this preview, maybe it's okay. I think it is fine. And let's say we want to go with 60% step over. Now, I really wanted to know which all areas it's going to go. I don't want to really spend time. How do I have 4 inches here, 4 inches here? Is it 4 inches? Can the cutter go inside or not? This is time consuming. I wanted to load the tool and say, okay, this is the roughing technology. I want to use it. I want you to go and find out if I can, what you will be able to cut. As you can see that I have this tool, and I'm going into my preview mode. And I say, okay, first of all, I have to select the geometry which I want to cut. Makes sense. So let's go back and say I want to cut everything I have it on the screen. So I'm going to go and say, okay, I want to cut everything. As soon as I come and select my surfaces and everything, now this preview will be active. As you can see that these glasses are ready. So I wanted to see what will be my remaining stock if I were to go with a 4-inch cutter, 100th hour down step, 2.4 inches side step, what will be my remaining stock? The system takes about 30 to 40 seconds, and I'll come up and say, okay, you know what, this is what it's going to look like if you go ahead and machine with these parameters. Now I can clearly see that, okay, you know, the tool is not going to go inside this. There's a pocket here which I won't be able to get in. It's able to get in, but it's going to leave some material here. In this area also, it's not going to cross over. So I get a good feeling about whether I want to use this tool or maybe I want to choose a different tool to do this operation. At this point, I can also go through the part and just do a cross section along Y and look at closely enough. Okay, yeah, this is, maybe I can live with it. I know this area is not good, and I can walk through around and make whatever I want to accomplish. And then I can go back and say, okay, let me try the 2-inch, what areas it would cut. So I just have to go back to from preview and go and change my tool. As you can see that I'm not calculating anything. I'm just trying to just see the preview of machining areas. I'm just changing the cutter and say, okay, if I were to use that cutter and do this, show me what areas, what would be my remaining stock. Now you can see that the 2-inch would get inside more here and probably more here and nicer clean here. There's no material left over. So it helps, and I just wanted to let the users, the participants know that this is not a small piece of geometry. This is about 46 inches by 36 inches part, and it's able to show us the remaining stock in about 30 to 40 seconds, and that's really, really quick, and this helps a lot. And not only that, there are analysis tools. For example, I want to know different radiuses on the part. I really don't want to go and pick on each surface and find out. I wanted to know quickly, oh, this is 318, this is 1/2 inch radius. What about this area? This is also 1/2 inch. It also color codes it so that you can see that you can see the ranges. Okay, you know, 0.127 to 0.76 is what 1/2 inch is, and it gives you a clear picture of, you know, which areas you want to go with a different cutter. Like for example, this is a 119 radius there. Maybe you will plan something for that. So it's very quickly gives you different areas, different radiuses of the part. This is some analysis which will help decision making easier. Then we have something direction analysis. I can take the whole part and say that, okay, I'm going to cut in Z direction. Show me if there are any undercuts. So, or pure 90-degree walls. Here it is, oh, okay, that's a vertical wall. Oh, that's 10 degrees, that's good. Oh, this is about 3 degrees, maybe not that good. So I can quickly analyze the part and understand what I am against. So this is, here it is. Nice one. So here you can see that that particular area is an undercut. Okay, maybe it is intentional or unintentional, but we don't know, but it is definitely an undercut from the top view. So it's very elegant, and also it gives you quick review of the part. So these analysis tools are very, very useful for the programmers to, if you have in your CAD system or if in your CAM system, you know, I think it's a very good thing to go and investigate and you know, analyze it. The next one I wanted to really cover, which is really it is how to say, the initial time required for this setup is maybe a few days, but the fruits, what you enjoy while programming is really tremendous. That is tools. Many programmers do not take time to define their cutter library properly. When I say properly is they probably have all the tools, diameters and corner radiuses and things, but when it comes to the shank and the holder, we don't take enough time to do this. Creating proper tool libraries along with cutting conditions will help, definitely help. 15 years back, if you go back, believing the values provided by the tooling vendors was risky, and it varied dramatically from actual conditions. But in the current time, in the recent times, the tooling vendors provide very accurate and proven cutting conditions, for different materials and different operations such as roughing, finishing, contouring. And not only that, they also give us that these conditions will work best with particular type of holder, particular type of fit, whether it's a shrink fit or collet checks or whatever it is. They also indicate that, and they give the values for particular material, particular combination, and tooling vendors are have become very efficient in this, because now they have capabilities testing themselves and proving it. So as NC programmers, we must take advantage of that and try to get that information filled into our tooling database. And some of these you can also automatically download. Cimatron works very closely with ISCAR. You can get the tooling information from ISCAR website directly into the tooling. Apart from that, there is always a very important thing which many CAM systems provide this, but not all programmers use it. Cutting conditions. Make sure that you have standard cutting conditions built into the tool, and how to use them automatically. That is very important. In Cimatron, you define these values, and at any point, if you go into the procedure, let's say if you are creating a finishing procedure, you just say that, okay, I want to use the cutting parameters defined in the tool. It automatically loads all those values, including your feed rates, spindle speeds, plunge feeds, down feed, and down step, side step. If it is plunging, what ramp angle it has to use. So you can define most of these parameters and get it used into the procedure easily. Holder gouge check is not new to CAM systems. However, there are CAM products which have the ability to calculate the tool path from the get-go with the gouge check, which is Cimatron's philosophy, is to create the tool path gouge-free first. But there are many CAM systems which calculate the tool path. Although you define the holder, it will calculate the tool path without the holder, and then you have to subject it to a check process where the tool path is trimmed using that holder. I think the system should calculate the tool path what is right from the first time, rather than going and trimming and editing it. One another important aspect I always share with customers and users is that make use of the tool checking on the machine. Nowadays laser check on a milling machine is very, very standard. If you go and buy a new machine, you probably don't want to buy it without the laser checks. But just having the laser check on the machine is not sufficient. You have to really use that to effectively help the programming and automatically checking the tools. I'll give you an example here. If I have my tools properly defined with the holder, with everything, when I post it, I just do one single program here, maybe the whole thing here. Let's post it. Maybe it will take a few seconds. Let's see the fire. There's a lot of programming there. Maybe I will select a few toolpaths rather than the whole thing, but it shouldn't take that long. I think I'm getting in the time here. It's already 2:42. Okay, so here is the program. Now I'm going to just go ahead and post, and on here I see, let me see here one thing, output tool center, treasury code. I think I have it. Oh, obviously I did a mistake here. I'm just going to close this. And I also want to just pick a few toolpaths, so I'm not taking too much time. Post process this with the laser. Sorry, I should have checked up that laser post. Okay, so I have it here with the laser. And I'm going to say that, okay, go ahead and post it. Now this is a post processor for a Heidenhain machine, but I think it is very important for good programmers to implement this in the shops. What it does is it takes the information from my tool library, and it says that, okay, you know, the tool total length is 6.5. That's what I've used for programming. And this is my diameter and the corner radius, whatever it is, or the offsets. And then it writes that into the system first, into your machine. This is what the writing portion of it. And then it goes and picks up a probe and measures the tool length. Not only just measures it, but what it does also is, I think I've used a post which is not the one which I want to use. Let's see this one here. Okay. Measure all tools at the beginning, output laser calls, yes. It not only enters that value inside, it goes and measures it, and if it finds that if the length of the tool is smaller than what I used for programming, it will say that, okay, you know, the actual length with which you programmed, where it is gauge checked, is 6.5, but the tool length is only 6 inches, so that means you're taking a risk. So what it will do is it will go and compare those values. You can see that it is comparing. If it is within certain range, it will say, okay, fine, no problem. That means if it is ½ inch more, it's okay. But if it is less than what you have defined, it's going to go and say that, okay, this is not the right tool you have loaded. So it's also checking that you have the right tooling in the machine with which you have programmed. And there are always easy methods to do it in the post, to check the tool if it is broken after every procedure is run, and then based on the result you can take a decision to stop the machine or not. These are very critical because nowadays we want to be efficient. We want to use the machines 24 hours. We wanted to run those during the weekends, light out. So in those circumstances, it is very important that you have the capability to do this that through the post. This is something for all the programmers to consider if they want to become more efficient and how they can use the machines effectively. Now I'm going to go into some machining strategies which would help programming. In fact, I'm going to create a quick toolpath here. So finishment all parallel 45 degrees. And just for the time purposes, I'm going to make it a little larger step overs. Copy and paste it. And I want to make it as 135. 7K. I have seen in many companies, just because we want to program it faster, take a job like this and run it parallel cut, one in 0, one in 90, and think that that is going to solve the problem. First of all, we are running 2 times on the 3D shape, which is not the best solution. I think it is very important that as programmers we have to take each region, break it down into different strategies to get the best results. For example, as it is calculating, one another nice thing is while it is calculating, I'm not stuck with the system. CAM system should be running all the calculations on the background. I should be able to continue my work without any wait. So here, for example, I have a, where is it here, local, yeah. I wanted to take this radius and finish it off nicely, running around that radius. I've already semi-finished the part, everything is done. Now I wanted to go to 0 and I wanted to finish it nicely. So taking each area and programming it separately, and the system should allow you to create those type of toolpaths is very important. Here the definition is just picking those top and bottom contour and the surface in between, and that's done, and this is a nice toolpath. Then I can go and see that there is a wall around, and I can just go ahead and finish that wall separately with probably a different tool, with a bullnose tool. And you can see that it is approaching from outside nicely. And when it gets to the bottom here, there is no step over anymore. It's all spiraling down in a continuous path all the way to the down, and then there is a final pass. So it's very nicely done. It is very important that as programmers we break down the areas how we wanted to cut it, rather than just taking everything and say, okay, go and finish it, you know, like let me see here, this toolpath here, a bidirectional toolpath going 45 degrees. It's going to leave this area not very good. So let's go back and do another one which is going to take that area. But I think first of all we are cutting more on the part. Of course it is quick. Of course it is nothing to worry about. You just select the whole thing and cut it. But this is not the best toolpath we should look for. We should always look at the area and how we want to cut it. Similarly, all the 3D slope areas, you can see that I don't want to cut this flat areas with a ball cutter. I want to just pick all the areas which are having slope and cut it with a a finish cut. And this particular toolpath is very nice. You can see that on the top radiuses it does a spiral, because if I were to do a Z-level finish here, it won't be nice. As soon as it comes onto a vertical, close to vertical area, it does a nice Z-level finish. I was talking about why this area it did not get in, because of the holder gouge check. We also have for a method, I want to calculate it, but also I want you to tell me what would be the length required. It says that, okay, if you were to have 2.48 on this tool, whereas right now the 375, let's see here, where is that tool? I can sort it by 375, not corner radius, where is the diameter? 375 diameter. It has about 1.7. That's why it's not able to go all the way down. And it says that, hey, instead of 1.7, if you had 2.48, you probably will be able to do everything without any problem. So it also calculates and tells me. And I can also do the calculation in such a way that, don't go and machine it and let me know how much I have to put it out of this holder, because I want to use this shrink fit holder for this cut, and it will tell you that as well. The other thing I want to talk about is the tilt machining. This is only applicable when you have a 5-axis machine. automatic tilting. Basically what it does is as much as possible it will go in straight, and as soon as it gets down to the area it automatically tilts and make sure that it is staying away. And again, you probably are wondering why this gap. There is no gap actually. This is the cut with the angle, and this is the cut with the straight. So if you see, the touch point is exactly the same. When it is in an angle, it is touching there, and when it is straight, actually the tip is here, but the touch point is here. So it's a nice tool path with automatic tilting built into the system. I also wanted to touch on sharp edges. This is very, very important to take time and make sure that we get sharp edges like we want. I have a simple example to showcase this so we understand clearly. Why is it? It's not calculated. Let me just calculate it quickly. It should not take much time. So this is a finish cut with normal parallel cut finish. But if you really think about it, I'm going to show you by navigating here. If I come here and then say, okay, start moving, maybe I will go a little bit slowly, pause it, forward. Okay, I'm going to go in the side view. You can see that it's already touching this peak here, the sharp edge, and so many points is doing nothing, but it's keeping that point contact, and then it's going. So the tool is idling here on that wedge or sharp edge unnecessarily and losing the sharp edge there. Whereas if you really think about this tool path, sharp edges, sharp corners. Okay. Yeah, here, this is the tool path I want to look at it. This one has a parameter saying that, hey, I wanted that edge to be really sharp. Where is it? That's not the one I wanted. Internal sharp corners. Obviously, this is not the right file, probably. File close, no. Oh, this is the problem. Yes, this is the one I wanted to talk about. I didn't want to go into the settings and recalculate, so I have a file which is ready for us. So this will be your normal toolpath where it is going to idle, and this is the toolpath which you can see that when it comes to the edge there, maybe let me make it a little bit different color so we can see it. As you can see that that's your touch point on the top edge there. Now it automatically lifts and goes to the other edge, and that's it. So this keeps this edge very, very sharp automatically. So this is something which is also important when you try to do sharp corners. You should have ability to do it. There are many ways you can do it. You can also say that, okay, at sharp edge, I wanted to extend it. So you can see that it just does the right-hand side separately and the left-hand side separately. There are ways to do that. So it's very important that you have ability to control the sharp edges. Multi-tool finish operations. This is very, very important as well. ability to define multiple tools in one single procedure. This is something very unique to Cimatron, I would say. Let me just go here, CAD tools, design. Okay, here, multi-cutters. Okay, where is the toolpath? Oh, I'm sorry, somebody calculated it inside that. So let's just hide it to show you the principle basically. Okay, here you can see that it's remachining that area, but it says that it has multiple tools. What does that mean? Let's see. I have the tool here, which is very short. This is fine, but if it goes further down, probably it is going to hit the shank. In the same procedure, I can bring in another tool. So what it is doing is it is cutting until here with the short tool with a different feed rate and spindle speed, and when it comes down, it brings up a new tool and starts from that height automatically and goes with a different feed rate and then spindle speed, of course, because otherwise we could use the longest tool possible. But this is more efficient because it is taking both the tools. It's taking the short tool and cutting it faster on the top, and then taking the smaller tool and going slowly and picking up the bottom, instead of cutting it with the long tool with slower feed rate all along. And this is just two tools, but you can have 2 or 3 tools. What is nice about this is if there is an area where here the small tool can get, it will go get that as well. So it is taking the holder and the shank gouge check, and it is going and getting everything what it can do from every place. Oh, the time is really Matt, how much more time we have? I see that it's 3 o'clock.
All right, it's 3 p.m. I think if we want to leave some time for questions, I'm not sure how much more you have to go through here.
You know, the couple of things I wanted to touch, at least maybe I'll talk about it instead of going into showing the operations. One is, which is very critical, is with the CAD system, the integration between the CAD and CAM. When you have a single system doing CAD and CAM, it helps a lot. One is you don't have any translation issues. Second is when you have changes in the model, many times some of the roughing and things like that will start much before the final model is available. So when you have an update, you can update it seamlessly without recreating the toolpaths completely. Maybe you just have to recalculate, but you don't have to repick the geometry or tool or anything. The other advantage is, especially in finishing operations and things like that, if one particular area is not affected, it will not flag that you have to recalculate them. The geometry will check between those two and says, okay, this is exactly the same geometry, it didn't change, so I didn't have to recalculate that. So there is a lot of benefit by having a tightly integrated CAD/CAM system. And also, when you get ECOs, you know, not just only ECO, but maybe repairs or something of that sort, it's very useful to have capability to define local stock and cut it. Just wanted to show you this simple example here. I have a ECO added. This was the original part, and then they said, okay, we need something in the center. Now I have started programming it, and now I finished it, decided that this will be an insert because the hole is already done. They said, okay, we'll wire cut and put an insert from the back, and let's get this. So probably the stock will look like this. They have added the piece inside here. So I can take the whole model and rough it, and it will only rough in that area. So ability to define multiple stocks in one single file is very, very handy when you have to deal with some small changes or some ECOs or some repair or whatever it is. I think that is what I think I can cover at this point, I guess. Probably another small thing I would touch is the ability. I was talking about re-roughing and mentioning about how important it is to know the material where it is. It's not only just for roughing, even for finishing it is important. For example, in this case here, I've finished this tool path cutting with a 1/2-inch ball and mill, and I wanted to go with a 1/4-inch ball. There might be areas where it might leave a lot of stock, so I should have the ability to rough them. If you really look at this tool path here, there is a tool path which is roughing first inside, and then leaving about 20 thou or something like that, and doing the finishing. This is your finish pass, if you can see my mouse, and this is the roughing pass. It removed the extra material first and then did the finishing. So it is very intense capabilities, and this is what the CAM systems should give the flexibility to work with, and the programmers should always take some time to program it properly so that we can save a lot of time on the machine. Another last thing I would say is when you have procedures, when you know that this will work, you can always make them as templates and apply to a new job. Selection of geometry by colors, sets, layers, these are all useful tools to speed up the programming. I sincerely apologize for going over time, but I think if we can take a few more minutes and answer some questions, I think it will be okay.
Sure, Harry. I think we have time for a few questions. Hello, everybody. This is Matt Danford again with Modern Machine Shop, and we just have a couple. If everybody has a couple more minutes. And just a note also, for those of you who came in a little late and missed the introduction, I know one person was asking if Hari could back up and show him something again. This entire presentation has been recorded and will be available in a few days, so you can go back through and watch the whole thing or any specific part of it that you'd like at your leisure. The first question here is when you're defining cutter feeds and speeds and the tool holder info, he wants to know how can you use a cutter from your tool library that has settings that the user's already established. How can you take that cutter from your library with your own settings and use that in the program?
Very simply, let me see. I did not go through this particular toolpath here, whether I have the tools defined with the parameters. Probably not. Let me open up the other one which I have the parameters defined so I can show it. Very simply, you right-click on the screen and say that, okay, I wanted to use the settings from the tool. I'll quickly show it. For example, here I wanted to create a finish procedure, let's say, a new procedure. It could be a surface milling finish mill. And all I wanted to do is I want to go and pick up a tool. Let's pick up a 125 ball. Let's make sure that there are some parameters. There are. Okay. So I picked up this tool, and I right-click and say, set all from cutter parameters. As you can see, the 6 has changed to 2, because 2 is the value I have defined it in this particular tool path for the tool. So all the parameters, spindle speeds, feed rates, what type of coolant, everything you can define in the tool and quickly use it, no problem. I hope I answered that question.
Okay. Another question. When you were in your rest area machining, you said it's very nice that you can do a re-rough, but he wants to know how do you handle that when typically the tool that you use for roughing is different than the tool that you use from finishing.
Very intelligent question, actually. It's nice. Definitely, there is not an automatic way, but Cimatron provides you that ability. Basically, in this is the example I was showing. Actually, just to show you that there are 3 tools used, and probably no, not this one. Let me go back to that particular file where I was using it. That was in here, remission rerough. Yeah. So I was showing that the reroughing inside built into the remachine area. So what I could have done is, if I wanted to use a different tool, let's say I copy this and just paste it. And in the first one, I would say, okay, I just wanted only rerough. I don't want to do the finish. So I can say that, okay, don't do the finishing, and only just roughing. So now it will just give me the roughing toolpath in those corners, and then the next one below, I will go and say, okay, don't do the roughing, just do the finishing. So now I could use 250 ball, but with a F at the end, which will differentiate it for finishing, and I can say that, okay, don't do the roughing. So that's very easy, and many customers do it.
Okay. And someone else wants to know, how many toolpaths can you calculate simultaneously? And also, can you have multiple jobs calculating at the same time?
Absolutely, yes. As I mentioned, the Cimatron believes in background calculations. You can calculate multiple toolpaths without any problem. For example, if I just go in here and say that, I just wanted to, there is a mechanism where I can say delete all motions, it will just clear everything. And if I go and recalculate it, I can execute all the toolpaths together, and it might calculate more than one toolpath. For example, the roughings, they are dependent on each other, because the second rough needs to know where the material is, so it won't start until the first rough is done. However, there might be some procedures which may not be using the stock that might start earlier than the roughing. So there are, depending upon how you program it, it can do multiple toolpaths at a time. And not only that, we also have ability to run multiple sessions. While it is calculating, I can go onto my desktop and say, open up another session of Cimatron, and I can open up another file which I want to work on while it is calculating. I set up all the parameters right, and I wanted to let it crunch the toolpath. Now I can go into another one and start working on this part which I want to continue. You can have any number of sessions, and it can calculate. Actually, there is no given limit, but again, your computer resources will determine how much you can do it. This also question leads into another important information I want to pass on is Cimatron also has what we call a superbox. That means you can have a computer which is dedicated for just for calculation. It doesn't have the capability of creating toolpath or anything. You just create the toolpath on your license what you are, and that computer will take all the calculations and free up your computer from calculating anything. So you can work faster on different things what you're doing. So it's a what is the right word? Standalone computing station. Basically, it does not require any monitor or keyboard or anything. It just has a license and install the software there, and it will be on the network. You can have 3 or 4 or 5 users sending programs to that, keeping your computer resources available for things what you need to do.
Okay, I think we have time for maybe just one more question. And I'm not quite sure. Let's see. He says, you spoke about adding a stock for an insert, but can you add it to the actual stock instead so that it can rough both parts?
Absolutely, yes. If I'm adding it to the actual stock, let me close this file and open it up. I think that was the drill mill. Okay. here in this case, I said, I have the stock, which is basically added because of the added insert or whatever it is. Okay. But let's say it was not the case, and they've added something on this top here. So I can go and say, okay, I wanted to add some material there, whatever maybe, not the right dimension. Let's see. Okay, I can get rid of this, and that small one. I said this is my new sketch, and I'll just go and add it as my solid. New extrude this one maybe in this direction, one side. Now I could have defined that as my stock, and also I can select this also as my stock, or maybe define it by two contours, I would say, rather than selecting this as one single stock. Contours, select contours, this one, and this bottom, or if I wanted to make it as a square also I can make it, and then say, okay, these are my stocks, and that's my top and bottom. This is my top, and let's take the top as here and bottom as this one. So that will be my stock. Basically, I'm making it as same height, but if I wanted two different heights also, I can do it by just selecting individual geometry and creating a stock. So it's possible that you can add it to an existing stock or create it as a new stock.
Okay, great, Harry. Thank you. I think that's probably about all the time we have for today. There are quite a few unanswered questions here. I'd like to thank everyone for submitting those, and rest assured that someone will get back to you on those. And as I mentioned earlier, the entire webinar is being recorded, and you can access that later. So thank you to everyone for attending. Thanks to Cimatron and to Hari Sridharan for providing this information. We hope you found it valuable.
Matt, before we go, I just wanted to read this quote which one of our customers said. After we did our evaluation, we found nothing that could beat what was offered by Cimatron. It's fast and easy to operate. There's no other software out there, but Cimatron is the only one that is made specifically for tool and mold shops. This is from one of our very good customers. I will give it back to you to wind up, but there was a question that they wanted me to do it again. Whoever it is, or if anybody else wanted to see something, they can contact me, and I can take time to show them.
Okay, great. Well, thank you very much, Hari. Thank you all for attending, and thanks to Cimatron.